AP Stats Quideo 4. So to kind of save a little bit of time, I will not read the questions since we all have the same questions, but they give you the whole and the alternative hypothesis as well, and they both are 31%, and they're saying that the mean is large, that the mean is smaller than the 31% given. So, and they give you the population, or excuse me, the population standard deviation of 9.6. And for question A, what is the sampling distribution of the mean percent x bar that the sample spends on housing if the null hypothesis is true? Sketch the density curve of the sampling distribution. Hint, sketch a normal curve first, then mark the axis using what you know about the locating the u and the standard deviation on the interval curve. So first things first, since they give you the null hypothesis of 31%, I wrote that down first. And I figured out my standard deviation is 1.518%. And I figured this out by using the sample means that they give us in the AP Stats Chapter 7 sampling distribution. I use this equation right here, standard deviation. So my standard deviation given, which is not 9.6, so 9.6 over the square root of my my population, which was 40 that they gave you in the equation, which is shown right here by my work, which gives me my 1.578, which is rounded up to basically 1.518%, which allows me to have my bell curve starting at 31%, which was again the null hypothesis that they give you. And so my normal, my population, my 31%, and my standard deviation is 1.518 to answer question A. And question B, suppose that the study finds that the X bar equals 30.2% for the 40 households in the sample. Mark this point on the axis in your sketch. Then suppose that the study result is X bar equals 27.6%. Mark this axis point on your sketch. Referring to your sketch, explain in simple language why one result is good evidence that average Cleveland spending on household is less than 31%, whereas the other is not. Okay, so to answer part B, I said my P, so my population, so X bar is larger than my 30.2%, which gave me 0.299, which is fairly likely to happen, and we would fail to reject the whole. And my population X bar would be larger than my 27.6%, which equals my 0.0126, which is unlikely to occur by chance done. So we reject the whole this time. And my 27.6% is actually better, is a better result because it has a wider range, allowing us to be more confident. And here's me right now all my points that they give me, my 30.2% and my 27.6%. Finally, for my part C, part of the basic question, shade the area under the curve that gives the p-value for the result of X bar equals 30.2. Note that we are looking for the evidence that spending is less than the null hypothesis states. So for part C, I said that the null hypothesis, or the whole, is 31%. So my X bar p-value is 30.2, which is shaded right here. So again, given my 30.2, I shaded left, which is less than my 31%. Time for the advanced question. Pew Research in November 2011 polled a random sample of 799 U.S. teens about internet use. 49% of those teens reported that they have misrepresented their age online to gain access to websites online services. So question A, find the margin of error for this poll if we want 95% confidence in our estimate of the percent of American teens who have misrepresented their age. So for part A, I use the formula, part A, I use the margin of error, which is ME equals my Z star, which would be my square root of P quotation 1 minus P over N, or my 0.49%. So 1 minus my 0.149% over the square root of 799, which equals my 0.035, which would be my margin of error. For part B, it says explain what the margin of error means in context. So I said we can be 95% confident that teens admit to misrepresenting their age online lies between 0.455 to 0.525%. And since we've been given our X bar mean of 49%, we can be 95% confident that our range is a little above and below that 49% range. For part C of the advanced question, if we only need to be 90% confident, will the margin of error be larger or smaller? Explain. So for my response, I said the margin of error will be smaller because we are willing to accept the lower confidence level, which means we can hold down the mean proportion more closely, making the interval narrow. Time for the AP question. Each person in a random sample of 1,026 adults in the United States was asking the following question. Based on what you know about Social Security system today, what would you like Congress and the President to do during this next year? The response choices and the percentages selecting them are shown below. 90% says completely overhaul the system. 39% says make some major changes. 30% says make some minor adjustments. 11% leave the system the way it is now. And 1% have no opinion. So for question A, find a 95% confidence interval for the proportion of all United States adults who would respond, make some major changes to the question, give an interpretation of the confidence of the confidence interval, and give an interpretation of the confidence level. My response is the confidence interval for a population, since it requires a large population, which is N, is my population. So N will be larger than 20 times the population. Is the sample considered to be large, which makes the sample to be considered large, since my NP hat, so my 1,026 people that were a part of my simple random sample of adults asked the question, times my 0.39%, or the people who said make some major changes, which gives me my 400.14%, which is roundabout the answer, which is roundabout the number of people who responded for major change. So to get my alternative hypothesis, I did one minus my p hat to get 1,026 times my 0.61, or my 61%, and that answer would represent my remaining population of the people who answered the survey question. And the computation of the 95% confidence interval for one population proportion can then be found as such. We are 95% confident that all U.S. adults who would respond make some changes is between 0.36 and 0.42%. And to go along with that, you can interpret the confidence level as such. 95% of the intervals generated using this method will contain a population proportion, so this method will produce an estimate to be 5% error. Part B of the AP question. An advocate for leaving the system as it is now commented, based on this poll, only 39% of adults in the sample responded that they want some major changes made to the system, while 41% responded that they want only minor changes or no changes at all. Therefore, we should not change the system. Explain why this statement, while technically correct, is misleading. And I responded, the statement is misleading because in addition to the 39% who want major change, 19% of these two groups combined represent 58%, which is larger than half of the sample.